So as I mentioned, I wear a lot of hats in Chicago. I do not consider myself a scientist. I was about, I don't know, 25 years ago when I was doing protein biochemistry. I used to be an engineer, and occasionally I wear that hat. Most of the time now, though, and especially in this context, I speak to you as a really, really impatient and slightly scared user with a pretty good BS meter. And that's kind of my job description day to day. That is, a pretty impatient user with a good BS meter. And I'm coming here today to ask for your help, because we in radiology are in real trouble. And I think one of the ways we can get out of it is by more efficiently translating what you guys do, not only in your labs, this meeting, your field, into what we do. As was mentioned in the introduction, about 15 years ago, we came up with some technology in the lab when I was in Pittsburgh that ultimately was commercialized by the university into a PACS. And I'm going to go into some detail of that as an illustration of how to really screw up, how to make every mistake in the book, and yet we kind of lucked out, and most people in retrospect consider that a reasonably successful translation of some principles in the lab that ultimately was translated into the industry and to users. This talk is actually a sequel to a talk I gave to the IEEE a number of years ago, and it's given me a chance to really think about this idea of translation and why we're not really effectively getting the ideas that have been articulated brilliantly by all these young investigators who have appropriately been identified today. Why is it that we have to wait such a long time to be able to truly leverage that technology in the real world? That's what I want to talk about today. You know, when I started off, thank you, it was actually quite simple. And when I tried to explain the fact, why is it that I'm scared today? Why is it that I've come to you to ask for help? It's because we don't have a lot of time if we're going to try to avoid what many people, unfortunately, at least in radiology, feel is inevitable. And part of the reason is that our problems today are very different than when I started off. You know, one of the nice things about it, I believe there's going to be a whole track in this talk, in this meeting, talking about the 30 years of PACS, right? We're having that kind of discussion. Well, I'm not that old. I would say I've been in it for 15 years. But when I look at PACS as an example of how you guys have successfully translated what you do in the lab to how I use it as a clinician, I see three distinct generations of that, at least in the PACS world, and I think this is germane to other fields as well. PACS was really easy 15 years ago. 15 years ago was about the time when I started in this field, and it was actually almost doable. You could almost buy it. You could almost actually make it work, almost. And the reason is that the use case was quite simple. The emphasis was on image management. Basically, get rid of film. Just be digital. It was radiology-centric. All we cared about was to be digital in the radiology department. And back then, big iron approaches were perfectly acceptable. Big, expensive networks, big, expensive clients, no big deal. This was not a bad time to actually start your research career in PACS because the problem was pretty limited and it wasn't that difficult. I would say that we are now in the sunset of the second generation of image management, where the themes that you would hear even in this conference, I would say, starting about, 7 or 8 years ago, you talked about workflow. In fact, even today, when I look at some of the abstracts in the PACS track of this meeting, you still have reference to workflow, an enterprise-centric bias, the age of the ologies, the idea that we are not the only ones that create images, there are other folks that create and consume images, and that we've thrown away thick client models towards web and thin client. And I would say this is about the maturation of this phase. That was pretty easy too. Unfortunately, now we're in the third generation, and this is problematic. And I kind of referred to this a number of years ago when I was at a users meeting at Philips, the need for meaningful innovation for meaningful use. I know a lot of you have heard about meaningful use, and the problem is we don't have meaningful innovation to actually address this. Part of the problem is that meaningful use, if you look at the guidelines, they are actually irrelevant for imaging. And so there's not a lot of meaningful use cases for meaningful use yet, but that's changing. I think the real challenge is that the realization that our stakeholders are beyond the enterprise, beyond our firewall. That when I talk about the cloud, I don't talk about persistent storage. I talk about the fact that our stakeholders are people that are not just in our department or even within our firewall. We're talking about our payers. We're talking about the government. We're talking about our health consumers. And our responsibility to provide services that are based on the interpretation and management and evaluation of image data go beyond that firewall. The emphasis now is justifying our keep. And this is where we're failing miserably in radiology. We have to have a way of navigating an incredibly disruptive environment. In a few minutes, I'm going to try to convince you, for those of you who are not in radiology, why this disruption has come about and why we're awfully scared about it, and why we need tools and we need a more accelerated, more efficient way of translation of what you guys are doing to give us the tools to demonstrate our value. Because right now, the tools that we have, the translation that has come from the lab, from the vendors, from laboratories like yours, to tools that I can use, are incomplete, inefficient, and immature. As a result, all they allow me to do is demonstrate a commodity level of service. The tools as they are now, as they have been translated now, do not allow me to differentiate myself. And this is a problem when you're talking about fighting any form of commoditization. So the danger is incomplete, immature translation. I think this was always a problem, but we could live with the inefficiency and incomplete nature of translation because we had a good gig. I mean, radiology, imaging was great, reimbursements were high, laboratory, NIH money was plentiful. We didn't have to be efficient. Now, unfortunately, for the first time, for those who may not realize this, there are radiology departments that are getting their pink slip. Now, I'm not talking about radiologists on the ground, on the floor, by the road with signs, will read films for food. That's not happening yet. But there are this idea of displacement, of prioritization where research requirements or research initiatives are being minimized because of increasing economic constraints is a problem. The misconception many people have, especially administrators, is that PACS and medical imaging is a commodity. You did a good job, thanks enough, good enough, get out of my way. It's good enough now, especially because we have other initiatives and we have such a debt, and we don't have time or resources to do anything more. PACS and medical imaging is a commodity, and this is a dangerous perspective. As I said, I think part of the problem is that the translation and transfer of what you guys do to tools that I can use is still incomplete, immature, and inefficient, and this is a bad time for that to happen. We need a more optimized approach in order to add value to our patient population, our health consumers, in a much more complex, demanding, and competitive environment. And I'll try to be more explicit in that in a few seconds. The problem is, because this translation is inefficient and immature, what we see is not what you get in the lab. It's not your vision. I know that. When I see the tools that Mary and Ellen's team comes up, they're fabulous. But because of things we'll get into, the translation in the real world is incomplete, inefficient. And it isn't allowed to shine. Your vision, your ideas are not allowed to shine efficiently or purposefully, effectively when I get a hold of them in the clinical context. And this immaturity of translation has actually been a threat to us in radiology because, as I mentioned, it only allows us to show our commodity side. It doesn't allow me to shine. And that's a real, real problem. And in fact, as I said, we don't have a lot of time to do this. So, for those of you who are not physicians, for those of you who really kind of not read a paper or hit around a rock, we're spending over 17% of the gross national product. That is unsustainable. And there are a lot of issues that affect imaging in particular. It's not important that you read all this sort of stuff. The bottom line is reimbursement over the last year has dropped over 35, now 40%. This is the technical fee. Okay, now, many of you may not realize this, but most of the profitability of not just the radiology department, but of hospital systems, healthcare systems, comes from the technical fee from imaging. How many of you realize that? Radiology, you must be a physician. Right? The technical fee. So when you're dropping by 35 to 40%, that affects not only radiologists, that affects the whole healthcare delivery system. This is a huge, huge problem. Because as a result, because reimbursement now is decreasing for everybody. It'd be okay if it was just radiology salaries. Hey, we get paid well enough. Right, Steve? We're okay. Okay? The problem is this is affecting a 30% cut in the operational budgets, the revenue that's generated by hospital systems. This has a trickle down that is amazing, and many hospitals have gone through this. And as researchers, you cannot say you haven't been touched. Okay? And this is a problem. Reimbursements, when they decrease for everyone, what that means is normal trust or collaborative relationships are severed when it's every person for themselves. And that's unfortunately the coarsening of the relationship I see in health economics. Competition is going to increase. The justification utilization is much more prevalent and onerous. Traditional fee-for-service is inconsistent with the normal accountable care organization. I don't care if people believe accountable care organizations are going to be real or not. The key point is, irrespective of whether or not the formal ACO model comes to be, a lot of it will have to do with the presidential election next year. But irrespective of that, the concept of alignment is inevitable. And part of the problem with alignment is that there is this incredible push for commoditization of medical imaging. The commoditization of medical imaging will be encouraged. It's encouraged by now because there are many, many stakeholders that benefit from that commoditization. Now, this is important to understand, and it may not, you may not have a lot of sympathy for us as radiologists, but I will tell you, if what we are is viewed as a commodity, the tools we use are also commodities. All right, and this is a problem. This is a problem. We have to figure out a way to demonstrate our value, and I think one of the ways we can do that is listen to you guys and help you out as well and come up with a more aggressive collaborative model. The concern here is that we in radiology, if you look at Michael Porter or anyone who has looked at any modern industry, there is always this normal dialectic between commoditization versus value proposition. Whether or not you're selling something that's an undifferentiated asset, a commodity, toilet paper, or you're selling something that is viewed as a differentiable value proposition, like an iPhone. An iPhone is a good example of that, because I know of no other industry that is more commoditized than the mobile phone industry. They'll give you the phone free, and yet many of you in this room are foolish enough to spend a 40% premium on a phone that has exactly the same components as any other phone. But you're willing to pay a premium because you believe it provides a differentiable value proposition. The integration with iTunes, the experience, the presentation experience. Doesn't matter. Doesn't matter. It matters to you, though, in the sense that you view that as a value proposition. So the question then in radiology is, are we a commodity provider or a value provider? And I would make the argument that the tools we use are critical in helping the consumer determine whether or not we are a commodity provider or a value provider. Now, before you make a judgment about that, I will tell you, industry, many stakeholders already have. As you know, if what you provide is an undifferentiated asset, toilet paper, treasury bonds, whatever, a commodity, the most efficient clearing mechanism economically is the auction, eBay, right? That's why when you look at treasury bonds, they clear by auction. Very efficient if what you're selling is an undifferentiated asset. This is eBay for radiology. It exists. Now, if you look at this, this is a great tagline. Get the best price. Notice it doesn't say get the best quality, get the best imaging, get the best efficiency. No, get the best price. In other words, the only criterion that this group is trying to sell radiology services to hospital administrators is price. By definition, commodity. Toilet paper, undifferentiated. I love this diagram. The only person that is of color differentiable is the health administrator. Look at all these other people. Gray, faceless, flattened. I love it. It's perfect. Okay? I can't make this up. It's great. Okay? Who are these? These are radiologists. Steve and I. That's us. Well, most people can't distinguish between Steve and I anyway, so it fits. Anyway, so I enjoyed that DICOM talk. Who? What? Me? I don't know. No, it's the other short Asian. Okay. Anyway, so other than Steve and I over here, the rest of us are also undifferentiated. This actually scares me more. This was an initiative from a few years ago from the EU. This is the same idea, less creativity. Yeah, I would just screw it, give up, just call it ARBE. Okay? But the idea is the same thing. It's a clearinghouse. It's an auction for radiology service. What scares me about this is that it was underwritten by the government, the European Union, and imaging vendors, our friends. Because they are not stupid. They also see this as a tapped-out industry, a commodity. Now, this is why this really does affect you guys, because what the industry says, when I talk to a lot, one advantage of doing the Stentor thing and being acquired by a company and all, is I learned a lot about the business of medical imaging and what makes them tick. And it's very interesting when you talk to the business people. They'll sit there and say, you know what, we love the fact that radiologists are commoditized. You go, why? It's because they're the ones who always make it tough to make the deal. When we write the deal, it's the radiologist that cares about image quality, or radiation dose. The hospital administrator just wants, bulk, best deal, most favored nation status and all that. Now, why this affects you guys is that eventually, if all we care about is commodity, if medical imaging becomes a commodity, there is no need to really progress and improve the quality of imaging or the efficiency of imaging or segmentation or any of the other things you do, because it's a commodity service. It's good enough. No need to optimize, no need to demonstrate value. This is a problem. In fact, as I said, there are a lot of stakeholders that will benefit from and facilitate this commoditization. The government likes it, payers like it, the health consumers like it, this commoditization. Because after pharma, as you know, diagnostic tests are one of the biggest components of the 17% of the gross national health product we're spending on health care. So here's another stakeholder that wants to facilitate the commoditization of radiology, and that's Wall Street. Basically, their big thing is we can't get our money, we can't get our growth, our 30-to-1 return on investment, unless we facilitate radiology group disintermediation. In other words, the severing of the trust relationship between the local radiologist and the hospital. Okay? By severing that relationship, bypassing the local radiology group, and working directly with the hospitals will be the most efficient money. This is the same strategy that the PACS vendors and the medical imaging vendors are having. Bypassing the people who were a pain in the butt. Making them a commodity. You guys are next. Because again, if the service provided is viewed as a commodity, I don't need cutting-edge tools. I don't need next-generation tools. I just need good enough. All right? And I don't think you guys are willing just to sit there and just do good enough, because I don't need half of you to do good enough. That can all be outsourced. So is this outsourcing working? Yeah, this is one of the largest radiology groups in North America. I trained at Stanford. Most of these guys were ex-fellows and residents of mine. These were one of my first customers of Stentor. I know for a fact that the health administrator, the head administrator of this, I didn't wake up one day and say, oh, my calendar is empty. I don't know what I'm going to do. Oh, I know what I'm going to do. I'm going to sever my trust relationship with my radiology group for the last 20 years. But that's what happened. Friday after Thanksgiving, every radiologist in that group got a pink slip. Interesting. This just happened how many of you read this one? This just happened, just a few weeks ago. This one, we thought in academics we would be protected. When you look, because there have been a lot of groups, scores of groups have gotten pink slips over the last 2 years. But they were always private practice, community practices. So we all thought, wow, we're in academics, we're researchers, we're okay. This was a pink slip from an academic radiology program in Detroit. The whole group got fired to be replaced by a teleradiology company. I actually, believe it or not, 2 weeks after this, was invited to give a keynote to the residency, the ACR residency chapter in Michigan. It turned out the residents of this group were there. And I actually asked, I said, so I don't get this. All your professors got fired? Yeah. So what are they going to do for teaching you? Oh, they gave us licenses to Amersys and StatDX. What? In other words, here's a website. Here's a URL. So this is happening. This is really happening. So if we are going to be commoditized, the issue then is, why do I need cutting-edge technology? Why do I need you guys? Okay, if basically it's good enough. Now, I would make the argument there's a way to fight this commoditization, irrespective of whether or not radiologists survive. And that's a good point here. I'm not sure. It may be just too late already for radiologists. But I don't think it's too late for radiology or medical imaging. Now, in fact, the vendors have already hooked that wagon. They're no longer hitching their wagon to radiologists. You may decide not to do the same as well. But I think the future of medical imaging is very rich, and you can articulate intelligently a value proposition. I'm not sure you can hitch it to us, because we may be, in 2 years, the cardiologists, just like the cardiologists. I don't know if you realize it. Do you realize that there are less than 5% cardiologists in North America that actually now have their own practices? How many realize that? That 95% of all cardiologists have just sold their practice and are now employees, commodities of hospitals. There's no such thing as private practice cardiology anymore. In 2 years, the ACC suggests that 100% of cardiologists will now be working for the man. Okay? Radiology may be next. So the challenge for medical imaging, so now I'm just going to forget about radiologists because we may be a lost cause, but let's talk about medical imaging. I think part of the imaging of medical imaging and the potential, the salvation to avoid this commoditization, because you got to understand, when you go to commoditization, the only criterion is cost, and that means oligopoly, consolidation, lay off most of you. This is a problem. It is the diversity of value that requires more intellect, more thought, more resource. So I believe we are caught between the rock and the hard place, and that is we need to use commoditization when it suits us so that we can drive down costs, but we also need improved value, and we'll define that in a bit. I believe value is a function not only of quality but efficiency and safety, and I think that's part of the problem. The places where I have failed in trying to incorporate efficiently, I'll use a perfect example. Dr. Geiger's lab in Chicago, world-class group. I find that part of the problem is that I, as an operational person, as the plumber, the geek who's trying to get this to work in the real world, have failed pretty badly in trying to actually integrate this in the real world. Dr. Geiger's lab provides the quality, the innovation, but without efficiency, it doesn't work in the real world. I think that's part of the issue, that you cannot be unbalanced in your translation. I think a lot of translations I see has to deal with the quality side, but not the efficiency side. It has to work in the real world. And this unbalanced approach, I'm going to give you a case example in a bit, is a problem. We need research and vendor partners, I call them arms dealers, that can provide meaningful innovation that will allow us to shine, or whoever will replace us, okay, to shine, to demonstrate that we're not toilet paper, that we're not a commodity. Now, there's some observations I have made that I think still hold. I think the successful transfer of technology from the lab to the clinics is challenging, not only for us in academics, but also industry. None of us get this right. It's difficult to cross that chasm, that cultural chasm between the users and engineers and scientists. And as a result, the offerings have been less successful than it could be. Now, vendor, there are two sides to any war here. C.P. Snow talked about the two cultures between science and humanities. Well, there's a similar kind of C.P. Snow-like culture chasm between you guys and people like me, between scientists, industry, engineers, and users, physicians, radiologists that use what you come up with. We, as users, will criticize you, vendors and researchers. You just don't get it. And there have actually been a lot of people. Anyone, Con, are you in the room? I mean, there are a number of us who've written editorials saying, you guys just don't get it. You just don't understand our needs. You cannot just give you these better segmentation algorithms unless they're integrated into our existing systems. You can't expect us to use your new approach if it doesn't also improve measurably in efficiency. Again, value is a proposition not only of quality but also of efficiency. I'm not going to go into this because it'll piss off too many people, so I'll skip on this. That's a line I usually use when I really get mad at investigators and users who basically say, well, you doctors are a bunch of idiots. And I go, well, that may be true. But at the end of the day, if it doesn't work for us, it doesn't work for our patients, doesn't work for the payers, doesn't work for the government, ultimately we will have very little patience for further translation. But to be fair, we don't get it either. We users are really problematic. We suffer from featureitis. What's featureitis? To me, featureitis is one of the biggest problems I had when I try to translate even stuff I invent to people like me who want to use it. And that is, the challenge is giving the users what they want rather than what they need. So when you do focus groups, that's why I hate focus groups. Users groups, experts, people like me. This is the biggest problem vendors have and even scientists have. They'll say, well, let's get a group of experts, world experts, a users group. And they'll basically select people like me. Why? Oh, because he's an engineer, so we can speak the same language. The problem is, I'm a different kind of creature. Okay? I'm an engineer. I'll talk that language. I'll have that perspective. But what I say I do and what I really do in the wild rarely is the same. What I tell you I really need this new algorithm, is not usually what I really, really need. And that is something that actually improves my throughput and improves the accuracy and outcome for my patients. The other problem, Dr. Geigel will tell you this one is true, and that it's really hard to get us to collaborate in any meaningful way. Okay? How many of you have run across this problem? None of you. All your radiologists are able to drop what they're doing and spend hours talking about how, we're just interested in RVUs. Well, that may be the case. The problem is, unfortunately, yes, we will not meet you halfway. You got to go to us, right? Is that a fair statement? Okay. Fortunately, we have a basic science group that is extraordinarily accommodating. They will come to us, literally will come to us, because we're so lazy we won't even leave our reading rooms. Okay. But this is a problem. And I'll get into why that's a problem in a bit. The other problem is my fault as well, because one of my hats I wear is that as I have the operational responsibility for imaging for the University of Chicago. And part of the problem is that we say we're an academic institution, and therefore we should facilitate collaboration, right? We say those words. We speak the talk, but we don't walk the walk, because we have inadequate infrastructure and suboptimal access to our production or operation environment or an appropriate proxy. Like our dev environment, I'm part of IT. We have development stage production environments that we test our systems. But do we expose them to our investigators so you can actually test at very early and very granular level hypotheses? No. You have to wait until you have the whole thing. That's a problem. Okay, how many of you have run across that limitation? When you're trying to test a particular hypothesis, a very granular one, which would require integration in a production or proxy production environment, and yet we don't have that for you. So you have to reinvent the wheel, or you have to come up with a simulated environment, but that's always dangerous, because that very rarely translates into a real environment. Okay? Can't even get HIPAA-compliant information or data to actually test your hypothesis. This is a problem. There are administrative barriers. I can speak for that. I am the physician officer of our HIPAA committee for the university. Most of the time, I'm basically saying, no, you can't, no, you can't, no, you can't. You can't do that. No, 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 I don't care. No, CAD, no, sorry. Enough said about that. Also, there's lack of net translational research governance, project management resource. Research has to be run like a business with real outcomes measured. Okay? And unfortunately, we tend not to give our researchers the resources necessary to actually run their businesses correctly in concert and in coordination with other enterprise or departmental priorities. This lack of strategic perspective is problematic. And there's no mature technology assessment. You can't prove your worth. So as a result, the only way we prove your worth is how much grant money did you get in? How much indirects? Rather than real value. How implementation of your technology actually improved my efficiency or outcome. We have no true mature technology assessment that's local to our environment to justify your keep beyond simply how much money you're bringing in. Okay? Adding efficiency is almost more important than bringing in money, and this is problematic. There are two cultures, as I said, and there's a problem with this. So when you look at this, when you have these two cultures, you have clinical users and vendors and researchers, you got two problems. We clinicians are looking for practical solutions to boring, mundane problems. I just want to get through the day. Boom, boom, boom. I want an appliance. You guys are hypothesis-driven. You're scientists. You're interested in solving the big problem. We are appropriately idiosyncratic. I know Dave Clooney hates that word, but it's true. Because by definition, it's the way I differentiate myself from commodity. No one is cookie cutter. How an ophthalmologist looks at images or patient data is very different than a surgeon, is very different from a cardiovascular radiologist, is very different from me, an abdominal imager. Okay? And we are appropriately idiosyncratic. Unfortunately for you guys, you're looking for universal truth. Okay? Shared, modeled commonality. Okay? The truth. When I'm saying there's no truth, everything's variable, shades of gray, and your mileage may vary. My problems are always changing and ill-defined. It's a moving target. You want precise specification. Give me the use case. Understand what the problem is. Define it. Well, by the time it takes me to define it, the problem already has changed. That's just the real world. There's an impedance mismatch there. I need it yesterday. How many of you heard of that? I need it yesterday. I need to have a very short expected deliverable horizon. You want a disciplined methodology, the scientific method, validation. Too cumbersome, too slow for me. More importantly, we don't give a damn what you do. We really don't. This is an appliance to us. You know, one of the biggest criticisms I have, I'm a big believer, I'm a big fan of usability. That's kind of one of the things I do. And one of the things when I look at presentation interfaces that come from the lab or for research groups from vendors is you can tell that this changed you love what you do. In fact, you want to show off what you do to the glorious detail. Hell, you just rather grep everything if you had a choice, you know, kind of stuff. At that level of granularity. Show how beautiful my architecture is. I don't care. I want you to hide that from me. I want a one-click, just do my job so I can get out of here kind of job. I'm looking for an appliance because your wonderful thing is peripheral to what I give a damn about. What I give a damn about is taking care of my patients, improving outcome. Now, if your tool helps me do that in an efficient and high-quality way that demonstrates value, I'm in. But I'm not in love with how you did it. Whereas how you did it is central to your reason to live. This is a problem. This is a big problem. So as a result, I am arrogant and ignorant. And you are arrogant and ignorant. And this is the problem in a nutshell when it comes to translation. We're two different creatures with two different kinds of ways of looking at the world. And here's the point. We got to work together faster, a more efficient way. And this is a problem. So why does translation occasionally fail? Like I said, we have significant shortcomings in trying to work together, and we miss the obvious. We miss amazingly the obvious thing. How can this be possible? Now, many of you in this room will say that it's not that bad. So what I'm going to do is I'm going to conclude by giving you 3 examples. 3 examples. I actually had 8, but then I said I'm going to run out of time, and I'll probably run out of time anyway with just these 3, okay, of examples of at least my own experience and other people's experience where incredibly bright people on your side and reasonably bright people on my side screw up and actually fail to solve a problem because of fundamental misconceptions and errors. And there are 3 of them here. Wrong problem, wrong solution. What do I buy about that? We talk about self-resonance. In other words, you guys are great scientists, great engineers. But here's the point. You tell any good engineer or good scientist, if you give them a properly defined use case, and in fact, if you actually define the problem correctly, almost every one of you will come up with the same solution. Here's the problem. What if you came up with the wrong problem? What if you defined the problem incorrectly? Missed the problem completely? This happens all the time. This happens all the time because you don't understand my domain, and I don't know about your job. I don't even know how to define my domain. This is a problem, okay? Self-resonance. Wrong problem, wrong solution. I made that error. I made a $12 million error. I'll get into that in a bit. Second kind of problem. Win the battle, lose the war. Even if you do figure out by some miracle getting the right problem, identifying what the real problem is, okay, and actually working with the domain experts and actually solving it correctly, you may win that battle, but you'll lose the war. Remember, value today is a function not only of quality. You guys tend to concentrate on quality, improved imaging, right? Improved information, extraction of information, or a more accurate way of doing things, greater precision, accuracy, quality. But if it doesn't also result in improved efficiency, it doesn't play in the real world. I cannot exchange quality for efficiency anymore. I used to, but not anymore. I have to have a balanced value proposition. Whatever you provide has to result in efficiency and quality and safety, all together at the same time. Perfect example of that, I'm going to go into MDCT and a lot of research. I just looked at every one of your abstracts in this meeting. Brilliant work. Can't use it. Sorry. And I actually tested that by actually sending every one of those abstracts both to the research division of a couple vendors, big vendors that make CTs, and then a couple of their business people. The research said, this is cutting-edge research. This is important. This is great stuff. I should be going to the SPIE. Oh, one of our, business guys can't use it. Never will. Show you an example. Win the battle, lose the war. And then the third model is, works great in the lab, but in the real world, not so much. That's more my problem. Operations. I call that the Geiger problem. Where they come up, it is, it's Mary Ellen, she comes up with these great things, and I screw up and never let it shine. Okay? Perfect example, CAD, and we'll talk about that. We're going to show you some of our own dirty laundry, okay, at Chicago. And then radiation exposure management, I'm going to show everyone's dirty laundry about that one, okay? But again, so those are three classes. There are a whole bunch of others, but these are three problems I see in translation. So let's talk about self-resonance. Wrong problem, wrong solution. The enterprise image distribution. Okay, I'll bring you back 15 years ago. 15 years ago. 15 years ago, the problem was, we didn't have to worry about anything. It was a simple problem. How do you get rid of film in the radiology department? Steve, remember those days? Those are easy days. That was when I first got into this field, okay? The problem then was, these are big image data sets. Pathetic now, but back then, they're really big. And we have limited IT infrastructure to support it. Our networks are sucky, and vast storage was really, really expensive, and workstations were really expensive as well. This was the day, the solution was, we're going to have independent. How many of you remember those days? How many of you have enough gray hair to remember that when we did PACS, we actually implemented parallel, separate networks? How many remember those? See, young people go, what? And did you ride dinosaurs on the way? I mean, just what? Kind of stuff. But yeah, that's how it was. How many of you remember ATM as a different kind of acronym? Do you remember that? Okay. These are the days. These are the gray hairs, okay? We use dedicated network infrastructure, multi-tiered archives with prefetch and dedicated thick clients. How many of you remember these days? Oh yeah, tape and all this sort of stuff. Dinosaurs. Well, that's how I got into this field firstly. And then we worked. We spent $12 million. The reason I left Iowa for Pittsburgh, actually, because they gave me a check to spend $12 million to do this overnight. And almost overnight. It's amazing what you can do with $12 million. Okay? Almost overnight, we were filmless in radiology. But here was the thing. I actually was asked to present to the board of directors of the University of Pittsburgh. They're all money guys. Say, okay, tell us what your result. Well, we spent $12 million. Thank you very much. And we're filmless in radiology. So how much money did you save? Is that relevant? Oh, okay. Well, actually, we're spending 40% more every year now. And you all know why. And this is the example of the first use case problem. We spent $12 million to keep a handful of radiologists happy, but we were still printing film for everyone else. We had completely misunderstood the problem. We did not anticipate that, wait a minute now, we have to have an enterprise imaging solution for everybody else, or else we're still going to print film. Because this whole technology was predicated on dedicated networks, expensive thick clients. There's no way we could have propagated that ubiquitously across the enterprise. So guess what? You're all going to get printed film. Now, just to remind you, we haven't completely solved it. Just replace film with CDs. We still haven't learned our lesson. Today, we have the same kind of problem in mindset. What went wrong? Let's analyze that problem. Again, crossing the chasm. Here was the problem, self-resonance. It wasn't the PACS vendor's fault. The PACS vendor did exactly what we told them to do, based on RFP. Was it our fault? Maybe. But we had David Gurr. We had people like me. We're supposed to be experts in this. But we screwed up. We did not even mention enterprise image distribution because of self-resonance. When I went to, back then, not SIM, but SCAR, when I went to talk to people like Sam Dwyer and those at SPIE and said, what do I need for a PACS? No one told me about enterprise image distribution. No one did. Okay? And so these traditional focus groups, committees, survey, marketing methodology, wrong questions result in wrong answers. Self-resonance. I don't believe in focus groups anymore. I hate expert users groups. So what did we do instead? Because we had just spent $12 million and we're ready to get fired. So we adopted an in situ R&D approach. We used something called extreme program. I'll go into that in a bit. Well, basically we said, guess what? We're going to do extreme immersion. I don't want to get burned again. So my developers now, you're going to wear white coats. Literally, they had to wear a white coat. Literally, had to take call overnight. Not IT call, but see what a surgeon has to do. What are the real use cases in the enterprise? And they had to stay there, and they never left. I mean that. Our developers wore the white coats and went to the users and never left. That's where they live, daily, on a daily basis. Users became project leads, but different kinds of users. Not people like me who are tainted because they were engineers or scientists in the back. In fact, the people we picked are the best doctors who gave a damn about patient care, whose VCRs blinked 12 o'clock at home, who barely knew how to check email. Those are the guys, those are the gold guys. Trust me on this. If you're building anything to work in the real world, you don't want to ask my opinion. Oh, give me grep. I like this. I want to play. I love what you're doing. No. You want someone who can barely check email, who hates this stuff, but cares about patient care, understands that this is needed, but isn't overly seduced by your craft. Because I am. So that's what we did. We used an agile software development with deep immersion called extreme programming. I don't want to get into this. Back then, it was a huge deal. Now, how many of you do agile? A lot of you do agile now. Well, not as many as I... Well, do it. Sorry. Now, there are a lot of different ways of doing agile. You don't have to be extreme. How many of you actually do extreme programming? A couple people, right? Okay. That's a tough sell because, having users, tolerate developers every day, sitting right next to them and videotaping them or taking notes sometimes is problematic. There are other forms of agile software development. Scrum. How many of you do Scrum? Those kind of things. Okay, there are like 5 different models for agile. I'm a big believer in that because you can interact with us at a much more granular, regular, intimate, reproducible, ongoing, iterative manner, right? We don't think in terms of alpha or beta build. We think in terms of daily builds where you test tiny little hypotheses, right? When you do that, it's not a big deal to scrap it. See, the problem is once you've come out with an alpha or beta of anything, you've invested too much to change fundamental hypotheses. Even if I tell you you screwed up, it's too late. Now you're going to just kind of fiddle around the edge and change the color of the button. That's basically all you can do. The beauty of Agile is its granular iterative methodology, which basically means you haven't been invested too much emotionally with your little widget. And if I tell you it's wrong, you'll say, okay, screw it, let's do it again. You won't be led astray. Trust me on this. This works. This really works. And I'm a big believer in this kind of thing. So we applied that kind of technology, that approach, to enterprise imaging. And so these were the use cases that came up, not by us, not by our vendor, not by the developers, but by this cooperative shared metaphor methodology, this extreme programming methodology. And it terrified the heck out of us because this thing went to the top of the list. And we said, how the hell am I going to deliver full fidelity images on laptops? That's impossible, okay? So we first did it, so we went to our engineers. I said, okay, we did this extreme programming bit. We listened to the users. We live with the users. Oh my gosh, every day we live with the users. And one use case that came out, one requirement is, the data sets are too big. That was the error I made. What I should have said is what the user said. I want full fidelity images. But instead, I played cute because I'm an engineer. I know what that means. Oh, that's impossible to have full fidelity. Why? Because the images are too small, too big. Oh, I'm clever. So I told my engineers, my scientists, make the images smaller. You see the problem. That was not the precise use case specification. The precise use case specification is, I need full fidelity images. I translate that inappropriately, thinking I was doing a favor, demonstrating my value as a translation guy, and said, data sets are too big, make them smaller. You tell any good engineer or scientist data sets are too big, what are they going to do? Squeeze them. Quantization-based compression. Here's the problem. Doesn't work for us because these data sets were very big, and even back then, 10-to-1 compression, which is as much as we want to do when we did our ROC studies, these data sets were still way too big. Okay, so back then, the problem we had was that even with 10-to-1 compression, when you still would saturate the network. The key point was not the size of the data sets. It was the transfer of the data from server to client. We should have been very pure and precise in our problem specification. Instead, I screwed up. So we were left with compression, and the problem was the compression squeeze wasn't good enough As a result, we were still saturating the network. That was the fundamental problem. When we finally realized that, we went back to square one and said, oh, I apologize. I was a terrible bridge person. Instead, the problem is not, forget data set size. The problem is, I need to get this very large data set to this client, and I'm very limited with respect to the network and to the storage of the local capabilities of the local client. You talk to an engineer and say, well, that's a different kind of problem. And what we came up with was something called dynamic transfer syntax. I don't want to get into it. People use it, and a lot of people, JPEG 2000 does it now, so everyone's familiar with it. We use a wavelet encoding, but rather than subsequent quantization, we basically used it in a just-in-time model. So basically the idea was, by understanding what the user wanted at a very, very micro-granular level, one could then stream at the level of what the user required by using this fuzzy logic thing with the mouse. But basically the idea was you could then service a lot of people. It seemed like everyone was getting what they needed, but the key point was the network was never saturated. And that's how iSyntax, how DTS works. Now, for those of you now, that was 15 years ago. Today, the next generation versions of that you'll see in JPEG 2000. In fact, there are a few abstracts today in your meeting in the digital pathology group. We'll talk about JPEG 2000. Same kind of concept, identical kind of idea, same idea. But here's the point. The engineer scientist could get this idea if you actually specified the problem correctly, and we did not. In fact, today there are other approaches to this, and now that the engineers understand that it is not the size of the data set that is the limiting factor, but the transfer of that from server to client, you have other ways of doing it, like, for instance, server-side rendering, where you need to consume volumetric advanced visualization. Almost everyone now is doing server-side, whereas 5 years ago, people were still spending the penalty saying all that DICOM there. So anyway, let's keep going. So that's the first problem. The take-home message there, avoid self-resonance. Immerse, incremental, agile development. Don't fall into the trap of self-resonance. Don't think. Keep the precision and the simplicity of the specification. Let the developer observe the user. Let the user define through their actions, not through their words, what they need. That was the mistake we made. So that's a take-home message for it. Number two, win the battle, lose the war. Multitexture CT. So, many vendors have told me, business guys, the biggest problem with multitexture CT is that it is now a high-priced commodity. What did I say a commodity? An undifferentiated asset. Can't tell one from the other. Okay? It's a high-quality commodity, but undifferentiable. Image quality is nice, but again, you cannot be unbalanced. And that's the take-home message of this use case. That you have to, if you're going to try to provide value, you have to not only provide quality, but you have to provide efficiency and safety. So, how did I learn this mistake? Learn from, it's always basically mistakes I've made. This is the first mistake I made in Chicago. You know, when I first got to Chicago, we implemented these 256 slice CT scanners, and we tried to justify the budget to the administration, oh, that would help. And they asked again, why and how, and go, well, it's very cool images. They're really, really pretty. Yeah, but has that helped me in the bottom line? Well, actually, no, it's actually not. And they said again, nice try. Come back when you actually have some news that helps us. So the problem, we went back and said, okay, we kind of missed the boat here, and that is we won the war. We have incredibly high-quality images for these new scanners based on algorithms that, oh, by the way, all of you have contributed. And yet, they weren't affecting us in measurable improvements in patient outcome. Why was that? Well, when you look at the reading room, because of PACS integration, we're paperless in almost every reading room in this country. Why? Because of seamless integration amongst the PACS, the RIS, the speech recognition engine. And yet, when you look at this, this is an old-fashioned 64-slice detector, obsolete by anyone in this room. Still works, though. And I can scan you from head to toe in a few seconds. What's wrong with this picture, though? It's empty. And the reason why it's empty is the reason why, you know, I show this as a use case. Unbalanced value. It's not enough to have pretty pictures. You have to have efficient pictures as well. And safe pictures. Value is efficiency and quality and safety. What's wrong with this picture? This scanner is empty. Why is the scanner empty? So this is one of the initiatives we started a number of years ago, called the Closed-Loop Imaging Initiative. Basically said, look, we have to, if we're really going to demonstrate the value of all these new imaging toys that you guys come up with, they've got to justify their keep, both with respect to quality, but also efficiency, value, safety. They have to, from a tech assessment point of view, which basically means we have to define our terms at a level that the hospital administrator will agree to, and that is the clock doesn't start in radiology. The clock doesn't start with that imaging device. The clock only starts when a physician, when she believes an imaging study is contributory to the patient, to the care of her patient, and only ends when that same physician, when she gets a collaborative message from me based on the interpretation of that medical imaging modality study. So when you look at that construct, we basically said, you know what we need to do then? We need to have much greater integration, coordination, and we have to start treating that CT scanner as an IT modality. What we basically are talking about is the biggest problem that we have in radiology now is that fancy scanner that you have built with those wonderful improved algorithms and kernels and all that other stuff. They still have not reduced efficiency or throughput in the department. You're still using humans, our technologists, as human integrating agents, typing from one system into another. Have you ever seen a technologist use your scanners in CT and MR? And how much time it takes? Because of the complexity you have added. Don't get me wrong, that complexity is better, but it adds to the inefficiency. And that's what we found. So what we built was this SOA interface, the SOA architecture. I don't want to go into it. I don't have time to do this. Basically, the bottom line is everything our EMR and our PACS and our RIS knows, we have normalized semantically into XML services. So now we can provide our vendors or our researchers at granular information that they can use to mash up anything they want, which is kind of a nice tool. So we built this tool and allowed us to do the following. We built an electronic tool, a carrot, that automatically extracts all the lab values, all the pathology, all the report in one-stop shopping so that the radiologist who protocols the case can get the information in one fell swoop, which is very nice. Why do we want to do that? Because I want them to get an electronic-based protocol. Why? I don't have a lot of time to go into this. Basically, we went with our vendor partner and said, now that we have exposed to you this information, I want you to modify the CT scanner not for improved image quality, but I want you to start treating it like an IT device that it is. And that is, the way it works at Chicago is when a patient comes in, the technologist doesn't set up the machine. The CT scanner looks at the protocol that was selected and automatically sets itself up, automatically programs the injector. After the scan is done, automatically orchestrates the workflow, like understands what recons needs to be done. You get the point. Very simple integration, but you're addressing not only quality now, you're also addressing efficiency. Does it work? It sure does. We've realized a 70% improvement in throughput. I mentioned that the reduction in technical fee was 35%. Now that I'm 70% more efficient, I'm whole again. Okay? So this is what the take-home message of this topic is you can't just win the battle, you got to win the war. And the war is value. Value is not just efficiency, is not just image quality, it's efficiency and quality as well as safety. Works great. Am I going over time here? I'm over time. Give me 5 more minutes. You okay? I don't mind people leaving. I doesn't mind. Okay. So the last theme, I told you, the last theme is works great in the lab, but. And this is another failure of mine, wearing my other hat. And that as the operational plumber responsible for the day-to-day operations supporting my users and my investigators and my researchers. I would say my harshest criticism is directed towards people like me wearing that hat. Because we really have screwed not only you guys in the room, but also my users. And a perfect example of that, here comes the dirty laundry, CAD and radiation exposure. So CAD, success story, but it's really tough to use. I'm telling you, I used to do breast imaging when I was in Iowa. I used to run the mammography section when I was at the University of Iowa. I'm glad I don't do that now. Because if I looked and if you saw how a mammography unit works in the real world, using all this wonderful CAD stuff that you guys come up with, because it's not seamlessly integrated, it adds to incredible inefficiency. The reason why we don't care is because we don't give a damn about mammography anyway. It's a loss leader anyway. So you might as well, doesn't matter, you know. But if we were trying to apply the same idea to something that actually generates revenue in the department, we would care. So this is a good learning laboratory. We need a better architecture to integrate from an operational point of view the great innovation that our science team in Chicago does. There's an impedance mismatch to the existing infrastructure. I'll give you an example. The first example is the following. This should be very familiar to Mary and Guy. You came up with this wonderful idea and actually demonstrated the improvement when you do CAD and also incorporate multimodality integration at the same time. Makes sense? The problem is, because we failed operationally to seamlessly integrate that presentation with the existing presentation, it added 20 minutes to looking at a case. So even though the ROC curve shows better A sub z, because it adds 20 minutes to the case, you think I'm going to use it? Well, they do in breast because it's part of a research project, but when you actually ask someone, are you really going to use it? Thank God, no, I'm not going to use it. Because it adds too much time. Now, whose fault is that? It's not the researcher's fault. My fault. Not understanding how to integrate this properly, not exposing the hooks, not providing a proxy environment to test hypotheses, not being able to be granular and componentized in trying to integrate these things. Routing DICOM data. Even DICOM data is difficult. We had to force our technologists to send images not only to our PACS, but also to the CAD server. This introduced more inefficiency. You see the point? So in other words, instead of making you guys look like heroes, you were the excuse we used when people couldn't get their images. Now, those researchers, they're just tying up our SCU, SEP, doing all those damn queries and pushing and all that stuff. Instead, now, we've learned. So over the last few months, we've installed an intelligent DICOM router. So now we can send to CAD servers and all that and support our research not only in CAD but advanced visualization and all that. In other words, the take-home message here is the other stakeholder here that needs to be engaged are the operational folks. That's my hat as well. It's my responsibility to build an architecture that facilitates granular, iterative collaboration with the investigator, with the users. Because if I don't, you're just a whipping post. You're just the excuse why I can't do anything. Another experience I would say that's problematic, I won't get into this, but I would actually like you to learn from us as well. Not just integrate it into our workstations, into our presentation experience, but understand my context as an imperfect observer. And that is, one of the problems I see in CAD is that it tends to maximize sensitivity at the expense of size. You tend to tune it in one spot. Now, I'm going to tell you something, just anecdotally. I used to hate when I ran mammography when my young mammographers would just come back from the RSNA or some meeting on mammography, because they would always start to overcall things. In other words, they would be over here somewhere, over here on the ROC curve. All right? And the reason was because I give those clinical talks, not in breast, but in abdominal imaging, in the kidney. I'm not going to show routine stuff and say, oh, that's a no. No, I'm going to show things that'll scare the bejeebers out of you. I'm going to show incredibly subtle things. And you say, oh, you thought that was benign. No, it's a cancer. Ooh, boogeyman. All right? Now, where do you think you're going to be when you come home? You're going to overcall everything. Now, if your CAD system is tuned, right now your CAD systems are tuned to one place and one place only, and that's basically to support an undercaller. What if I'm an overcaller too? All right? I would like you to know. Is Kevin Birbaum in the room? This is his idea, and I wish that someone had actually done it. I've tried to convince someone in Chicago to do this idea of the proactive hours. You know what I would like? I would like you guys, the first time I authenticated my PAC system, I would like us to say, Dr. Chang, you're slipping on the ROC curve. You're tending to overcall calcifications. You're tending to overcall mass lesions. Let me show you the last 20 cases based on our path-proven pathology where you've overcalled. And here are some relevant teaching files and articles directed towards you, the undercaller. And now the CAD that we're going to use is going to be tuned towards your problem. And that is, it is going to overcall because you're undercalling. Whereas if I'm you get the point. Okay? You don't want two overcallers, because then you're going to do a lot of biopsies. And that's a problem. So I would like those cues. My wish list for CAD is I would optimize the CAD system to match my user-specific characteristics. I would like to leverage clinical context, get better integration, no pathology, no lab values. I would love better integration in my workflow. Most of the stuff, as I've mentioned here, basically means I need to do a better job operationally to integrate. Radiation exposure, I'm going to piss off too many people in this, other than to say what we're doing I think is wrong. Maybe I'll just skip just to this slide, because I'm running out of time. Okay, I know you guys, look, all these registries and all that. I'm just going to show you this thing. I showed this at the RSNA talk on business intelligence analytics. These are two patients about the same size, same age. Here is a dashboard that you all show. You guys all show that, oh, this is why we want to do our registries and all this, because then we can show in CPOE, oh, this woman is, you want to order a CT, ooh, they're in the red, overutilization, ooh, scary, scary. Here's a patient who's about the same age, where 21 CTs is still, that's not so bad. Now, I'm going to tell you something. Every time I look at your literature on radiation exposure, okay, many of you understand that you just simply can't take the CT vol or DLP. You need clinical context, at least the patient morphology, patient age. You guys get that. But that's not enough, okay, because that, by definition, if you just took that, these two patients should have identical warning. Yes? If they're the same size, same age, same radiation, why is this one in the red and why this one who has more CTs in the yellow? It's clearly to make a judgment, you have to go beyond what the machine is doing, beyond the patient context, to the clinical context. The reason why 21 CTs on this person is maybe not unreasonable is because this patient has cancer. Okay? And that's why we do CT scans every 3 months for a while, every 6 months and all that. And it may be or it may not be, but the point is it's not an outlier. But you don't know that. And I think part of the problem with a lot of this radiation exposure, this process is being co-opted by you guys and guys like me, IT informaticians, ignoring the clinical context. If you're going to do this, you need to go beyond that and integrate the clinical context. The reason why we were able to generate, this is not dummied up, this actually comes from our collaboration with this company, with our SOA, because we can actually feed the diagnoses from our SOA interface. So this, again, is a failure of mine as an operational person. If you're really going to do radiation exposure, you need a complete context, not just the machine context, not just the patient morphology context. You need the clinical context. That means greater integration capabilities that I need as an operational person to supply you. So I'm going to finish by saying, you guys have done a great job. You are heroes in my eyes. We stand on your shoulders to provide care using medical imaging for our patients. And it has resulted clearly as an important contributor to outpatient outcome. The problem is this recent dramatic disruption requires significant improvements in the translation. We have to do a better job because the translation, as I said, is inefficient, too much latency, and incomplete and immature. We need a more agile, aggressively collaborative relationship amongst all you people so that we can play the value proposition game rather than the commodity game. And improve models for collaboration, as I mentioned, the ability for operations to provide better infrastructure for you to test your hypotheses at a more granular, iterative manner. The adoption of more agile, interactive collaboration models rather than focus groups, where users and you guys work iteratively and intimately with a deep immersion is something I would recommend, because this is going to be required to more efficiently provide, as I mentioned, meaningful innovation and translation for meaningful use. I apologize for going over times. You've been extraordinarily patient. Thank you very much, and enjoy the rest of the conference.